Hello everyone and welcome to part 1 of this tutorial series. If you haven't already, take a look at part 0 if you want to know what the final product will look like and why I'm making this tutorial series and the format of it. So hopping right in, let's get down to cloning the repository. After that, we'll work on looking at how the pawn code works, controller code, interface code. We'll set up our inputs in Unreal Project, and then we'll extend some of our pawn code in the blueprints. Also setting up our game mode a little bit. All right. If you haven't already installed Git Bash, we went over that in video 0. But for those of you that have, you just open it, Git Bash. Let's maximize. Then go to Documents, or wherever you have your Unreal projects. But for most of you, it's going to be Documents, Unreal projects. Then we're going to go to GitHub, and we're going to, so if I open Edge here, go to GitHub. I'll have a link to this in the bottom so it's easier to find it. But for the meantime, go to Ball Tutorial here, copy, Git, clone, control, paste here. Now there's an annoying thing when you paste. You have to go back here and delete 2 characters sometimes, or it'll mess with you. I'm going to clone this into tutorial because I already have a directory under Ball Tutorial. Let's check out the tag of the video that we're on into tutorial. Git check out part. I've now opened the directory in Windows, and I'm going to open up the project. There should be another build there, and I'll probably skip through that as well. Yeah, and then just hit yes. All right, let's start with some of the code. Going into choose a path here. Go to C++ classes, Ball Tutorial, and let's take a look at our rolling ball. Now, before we're able to access any of our C++ files, we'll need to generate the Visual Studio project files. So you're going to right-click your uProject file and generate Visual Studio project files. I've already done this, so it should be fairly quick. Okay. Now we can go back to Unreal and double-click on our rolling ball. Okay, now Visual Studio is open. Let's take a look. So up here I have a bunch of different includes. Then we have our main class, and we create a root component. So this isn't actually a visible object. This just acts as a container that we'll set in the blueprint class that extends. Then we set some variables. So we want physics on our object so that it can move around. This is so that it doesn't get stuck to the ground. This is a spring arm component, so this isn't a physical spring. This is more of a concept that your camera, if it runs into a wall so that you're not looking at the back of something or you're not inside something else, the camera will automatically adjust if you have it set to. But springs are generally for holding a camera. This set absolute makes it so that as our ball is rolling around, our camera isn't rolling around our ball. And that is the y-axis that we have set to absolute. This is rotation of our spring relative to our object. This is how far away our camera will be from our object, and then we're simply attaching the spring to our object. Then we have our camera. We create a basic camera component, and we set it and attach it to the spring, not to our base object, but to the end of the spring so that it's far away from our object and can look down on it. Then we're just going to set a little bit of a rotation so that we look a little bit more forward than looking directly in the angle of the spring. Basic begin play. Now tick. This is where any inputs you've made are going to take effect. I believe under the hood physics is also handled in tick, but we don't have to explicitly do anything. The engine handles all that. So this first bit is adding a directional push to our object. This is something that will take effect even if we're flying in the air. So we have half of our force in there. These are our inputs. So if you're holding both right and left, you'll have -1 plus 1, which will be 0, so you won't go anywhere. Same thing for a head. And then this is a direction vector so that we can be going forward and to the right at the same time. This is for use with get unit direction vector, just to make sure that going forward and right doesn't go faster than just going forward. If you don't have a unit vector, that can be an issue where 2 inputs go faster than just 1 input. Then this is how hard we want to push. You could make this public and blueprint editable if you want to be able to edit this from the blueprints. I like where it is currently, so I don't have that set up. This is for if we change our camera angle, like we look to the left, we also want forward to change. So that's what this does. And then we add force in the direction we're looking, or if we're going to the left, it'll be the left of the direction we're looking, or if we're going left and forward, it'll be forward and to the left of where we're looking. But the main point is that we're adding a force relative to where we're looking. That's the point of rotated unit direction in here. This is torque. So the nice thing about this is it adds a little bit more force to your object when it touches something, because it's actually a physical aspect that you're rolling your ball. Another thing this helps you do is this lets you go up hills a little bit easier, because if you're just adding a force, you're kind of running yourself right into the wall, whereas if you're adding a rotation, that helps you climb just that little bit better. It also has a nice effect where if you're in the air for a little bit, you start to build up torque, and then as soon as you hit the ground, you launch forward. This is how we rotate our camera. So if you want to look a little bit to the left or a little bit to the right, we just add to the world rotation of our spring. We're not adding to the relative, we're adding to the world. Or world or absolute is another way to put it. These are all called from our player controller. The reason I don't directly have player input set up on the pawn is if, let's say I have a boat pawn or a bigger ball pawn that you might want to switch to, or let's say we switch to something else. We're going to have different functions, different functionality that we want for each of those things. And if the inputs are all directly in the pawn, you can't easily change between which one of them is active. That's where the player controller comes in. So let's take a look at our player controller. All right, so here we have each of our inputs names. So the way you'd set these up is you'd go into project. Well, you go to edit, project settings. Then you'd go down to input. Then I already have my axis mappings put in, but you can add them with this plus sign. And I've also set this number to be negative for backwards and positive for forward, just to make things a little easier. I could use action mappings, but there are a few slight advantages to working with axis mappings. I know that's what they, normally you would have the axis mappings tied together. So I could add a second axis mapping here and have W be 1. But let's say I want a shielded unit or something that has a really heavy thing on their right side to be a little bit slower when they move to the right. Or most objects, when you think about them, are a little bit slower when they're backing up. So I wanted that functionality to be tied and editable from code. Like, let's say, I don't know, any imaginable reason you might want to have these functions separated. Okay, so that's the inputs. That's what we're referencing in our player controller here with this word. This word has to match the name in the input that you set up. This is our function that we want to call, and the word this here is referencing the player controller. So saying bind this player controller to this name from our project settings and have it call these functions. So what these functions do, and this seems a little silly, I know, but it allows us to swap out a different pawn. So all this function does is calls the function on our pawn. But if we switch to a different pawn, that might have different functionality. Now, C++ doesn't like it when you're not specific. So the way we get around that is we work with an interface. So let me pull up my interface really quick. All right, so this is just a simple interface. The way I made this is I inherited from Unreal Interface, then I named it and made some modifications. But this is how you'd make one of these if you had to make one. There's a different way to do this if you want to access them from blueprints, but personally I only need access to them for C++. These functions don't do anything on their own. All they do is they say anything that inherits from iControllable interface it guarantees C++ that they have these functions. So why is that helpful? Well, because notice that I'm calling move right on iControllable interface. So I can swap another type of pawn that is of iControllable interface out for my current pawn, and C++ knows for a fact that any pawns that are iControllable interface have a move right function, even if those move right functions are different. So that's what the interface is for. So now we have our interface for the player controller. And we have our player controller. I think that just about covers everything. So we can move on to blueprint inheritance and game mode. So let's go to blueprints, controllable, and let's take a look at our blueprint class here. So the basic C++, if you notice, I didn't set a static mesh or a material. So this is where, let's open the full editor here. This is where I would set those variables over here in details. So I set sphere to, I had to go to view options, show engine content, because the starter content sphere has its base at its bottom rather than at its center, so that makes it hard when you're trying to rotate it. So you just type sphere, and then I went with the engine basic shapes sphere. I've already done it, so this will already be done for you, but if you wanted to do this in the future, this is where you'd have to go and set this. And then I just went with one of the starter content materials. And that's all I had to do to finish the setup for this blueprint pawn. To create this blueprint pawn in the first place, I just did blueprint class, all classes, then rolling ball. And then I clicked rolling ball, and then I clicked select. So you can even see here, we have our blueprint as a subclass of rolling ball. So now, how does our game know to spawn this rolling ball when we hit play? That is handled in game mode. Game mode has a bunch of other things that I'll cover later on in this video, but the ones that I want to focus on right now are rolling player controller. This is what controls. This is what gets controlled. And let's take a look at somewhere else we can see that. In world settings, you need to, if you want to change game mode, you need to set it here. And then because it's a blueprint, we're able to edit these. If you have a C++ only game mode, you cannot change it from the editor. So with that, we have set everything up. Well, everything was already set up to begin with, but if you needed to change any of this, you might be able to. So let's hit play and see what it looks like. So we can look around. If we hit the W key, we can move forward. Q will turn our look direction. You can see we're moving with momentum. We're not just instantly going at a set velocity. I think I might need to rebuild the lighting as it says up there. That's why it looks a little bit weird. But all I would need to do for that is hit the stop key and then build. And now that it's built, it looks a little bit better. Okay, that's it for tutorial 1.